I'm Kian, and today I'm going to teach you how to prove if a sequence is convergent or divergent, and also if a series is convergent or divergent. If you have the sequence but we don't know the formula for a sub n, the sequence terms are sine of 2, 2 times sine of 1, 3 times sine of 2/3, and 4 times sine of 1 over 2. So using this, we can form the a sub n, which is a formula for the nth term of the sequence. So we can see there's one number multiplying by sine. So we can agree that there's n times some value that will give us these terms. But what is that value? So if we put the value, we can see that this n is just multiplying by sine of 2 over n. And if we want to check, we can put 1, we get 1 times sine of 2 is just sine of 2. If we put 2, we get 2 times sine of 1. If we get 3, we get 3 times sine of 2/3, and so on. So now for checking that if a sub n converges or diverges, we should take the limit as n approaches infinity of n times sine of 2 over n. Now, this limit is a little hard because if we put infinity, we get 2 over infinity, which is 0, sine of 0 is 0, and you're doing a limit with 0 times infinity, which is not determined, and it's not determined in limits, and it's not defined. So we can use one limit that varies. It is very famous for calculus students, and that limit is the limit as n approaches 0 of sine of theta over theta, which this, using L'Hopital's rule or any proofs, this converges to 1. So now if we want to calculate this, we should use substitution for calculation of this. So what we should do, so we can let theta to be equal to 2 over n. Now, if theta be 2 over n, what is n? So n, if we multiply both sides, if we take the reciprocal, we get n over 2 is 1 over theta, or 2 over theta is n. So we can write it down that n is equal to 2 over theta. Now, we can plug in the numbers. So we can write, and because we are changing variables, the number that n approaches also changes, and we get n approaching 0. So what we should do is that now we use this substitution to write the limit as n approaches 0 of n, which is 2 over theta, times sine of theta. Now, if we simplify this, we get 2 sine of theta over theta. So because 2 is a constant, we can take out of the limit. So we can write this limit as 2 multiplied by the limit as n approaches 0 of the sine theta over theta. Now the limit as n approaches 0 of sine theta over theta, we prove that this is equal to 1. So the final value that the limit as n approaches infinity of a sub n converges is 2. So we can say that a sub n converges to 2. So we can say that a sub n converges to 2. Now I want to show you, I can make parts. In this part I want to show you how to evaluate the series. So we have the series as n equals 1 to infinity of a sub n, which is just n times sine of 2 over n. And I want to see if this diverges or converges. So we see that we can use the test for divergent to find if this series diverges or converges. So for this, we should take a look back to what we did for proving the convergence or divergence for a sub n. If a sub n approaches 0, then we can say that converges, because any number, like any value other than 0, we can say that the series diverges. But if it's be 0, we can conclude that the series convergent. So we can see that the limit as n approaches infinity of a sub n, we prove that this is equal to 2. So we can say the series from n equals 1 to infinity of n times sine of 2n is divergent because we can now use the definition of limit. The limit as n approaches infinity of a sub n is equal to 2, which is not equal to 0. And if you want to write the formula we use, it is test for divergence. Thanks for watching. Please subscribe and let me know what to do next.